Hey, all you cool cats and kittens. Let's do some review. All right, here's where I believe we left off yesterday. So take a look at the image and I'll give you a countdown. What in the world's going on? What do we see here? What do you know? Access as much as you can in memory and then add whatever it is that I'm adding that you didn't already get. All right, in this case, we've got reproductive cells. In this case, you have sperm and an egg, as we are going to be sexually reproductive. In this case, it's humans. We have one, and we end up with, uh-oh, what the hell happened there? There's two of them, it looks like, down there, and then two and two, and we ended up with two down there. Okay, so in the case, we're obviously going to be talking about twins. Of course, you could have more than that if you're talking about multiples. Identical twins, if you have one sperm, one egg, go together, and then we end up with a split. The other term you could see for, although I wouldn't anticipate it on an AP exam, identical twin would be mono for one, monozygotic. Zygote's then going to split. And while I'm at that spot or saying zygote, let's go ahead and pause for a second and do the order of development. If we're talking about a human, we have a zygote, and then another thing that starts with an E, none of those. And then if you get born, you end up a one of those. And it's going to be Z for zygote, E for embryo. After the first 2 weeks, then we're in the embryonic stage. We can start to see some differentiation of things. We got a fetus for the remainder of the term of pregnancy, which is usually closer to 10 months as opposed to 9. It's a 40-week process. And then I for infant once they're born. All right. And if we're looking at utilizing what in the world we can actually do with this same sort of a thing, or with twins, the point in research anyway, in a psychological perspective, would be that we've got, if we're looking at the difference of genetic material nature versus some nurture stuff, identical twins are going to provide you as close as humanly possible anyway, to the exact same thing. They started off as the same zygote on conception, so when sperm joins egg and you have a viable fetus eventually, and then infant. Even though from the time of split, even in utero, the environment's going to be slightly different. The thing that actually connects or hooks up so that mom is able to gestate and feed the infants, the placenta, can provide for some different nutrients, which could account for some of the difference there. But as soon as you've got an environment that starts interacting with whoever the individual is, say just like various beverages, whatever it is that you're doing, drinking, exposing yourself to, language you're being, you're hearing, all of that stuff starts to change, and then certainly can also change some of the genetic material. So if we're talking about trying to figure out differences here, ideally the best thing would be start off with the same genetic material. You're starting off with identical twins, as opposed to, this one starts with letter F, we have fraternal twins, 2 sperm, 2 egg. And if you've got that, you almost certainly end up then with 2 separate placentas, feeder tubes and waste disposal units in utero. And because you end up with 2 different ones, the sperm's what's going to account for the chromosome that will be either an X or a Y, causing that to end up being male or female. Male if you've got a Y chromosome on the sperm, and then you can only have an X on that 23rd segment of the chromosome. So XX equals female. You could certainly with fraternal twins have same or opposite sexes depending on what the sperm's got. But you're always going to be the same, always going to be the same, always going to be the same sex when we're talking identical twins. Gender is a perception of self. So in that case, gender could be either, both. Doesn't matter in this case. All right, let's do another thing. In the image below, what can we detect through bottom-up processing versus top-down processing? So we're getting into some sensation stuff. All right, here's a pain in the ass. Go ahead and see what you can think of for that one. Hit pause. Okay, so if we're attempting to look at what it is that we can see through bottom-up processing, that's going to be from your peripheral nervous system to your central, up to the brain, up to the spinal cord, up to the actual processing or thinking about whatever it is that's going to be going on. So what sensations, probably if we're looking at an image, what sensations is it that you can see here? Well, if I'm looking at this thing, I see light. Ooh, don't get caught up or thinking that your top-down processing is what you're sensing. That's what you perceive. I'm seeing light and dark There's going to be some darkness gradient in there. They've got slightly different color that you can pick up on and stuff like that. And contrast of, in this case, what perceive as letters, La Vie en Rose, something about the rose. Isn't that from the movie my wife's obsessed with? Lady Gaga, Bradley Cooper. It's going to come to me. I think that's the song she sings. Anyway, so if you're seeing something and you perceive a rose, what you're seeing is the light on here, and you're seeing or perceiving some sort of arches. I'm perceiving some sort of a frame-like thing. That looks like then that would be green, and my perception, my top-down processing makes that even more green, more vividly green. And this is absolutely not something that I have a sensation of being red on here, but I certainly perceive it as being a red thing now that I think that it's going to be a rose. Perception is what your brain's doing with the information that's coming in, and the sensation is going to be what you are actually receiving. What's going to be the tactile if it's a touch thing, or the acoustic, the auditory, if it's a hearing thing, etc. I'm going to try this one. Stuff that we should be able to pick up with, or that should have some sort of impact if we're looking at the image there. A line, and semicircles that are still connected have some sort of continuity, versus, okay, if you're in a math class, your mental set, the way you're probably going to approach this would be that it's numerical. I would probably then end up seeing some sort of a 1 and a 3, as opposed to if I'm sitting where I am in my kindergartner's, or my kindergartner, preschool, my little toddler's playroom, right? So I'm going to be more likely to think letters, if that's the case, and that makes this that's a B. It's a B for Billy. His name's Billy. It says Billy over there on the chalkboard, and his B kind of looks like that. Sensation, what you're picking up on or getting here. Red light, in that case, that bounces off of this and goes to my eye, versus perception. The way you pick up on it. Priming, if I'm going to try and get you to either access some sort of a memory about something, or if I give you this visual cue and then we talk about it and you recall it, that could be a priming kind of a thing. Or the context, again, would be very much like your mental set. If you put an A on one side of it and a C on the other side, most people will pick up quite easily that that would be a B then in the middle. All right. Here is an image we looked at once upon a time. In this case, it's going to be largely cultural, how that changes your perception of things that's going to be going on. Is this going to be something tribal, East African maybe, and you've got what's more likely to be a woman with a box on her head, and this would be a tree? Or is it going to be more of a Western culture thing where you're going to look at this as being inside, there's a pillar, and then that's going to be a roof that goes over the top, and clearly then we would see that as going to be not a box on the head, but a window, because they are indoors. Expectation, cultural context, various cues like that. So you could see it one way versus the other. Oh, here's a good one, vision stuff. Okay, if we're looking at this guy, we have a prism and we put white light into a prism when we're talking about chromoception, your color vision. We then break it down, you end up with all of the colors in the visible spectrum, which might as well do a quick thing on in case that were something you were to get asked about. They break down into red, orange, yellow. I'm not doing a very good job putting this where it goes. Green, blue, it's not true, but we say indigo, and violet. Those are actually the same. But we're going to say that there's 7 different things because Newton said it was. Right? And that's this teeny tiny little sliver in the electromagnetic energy spectrum, that little band that we then view as light that goes to the eye. We sense whatever the wavelength is going to be, and that's going to change what it is that we see, or change which cones in the eye on the retina are going to pick up on that color vision. Again, cones see color. They're in the center, nearest the best spot for vision, nearest your fovea. All right, and then depending on if you go down or up in orders of magnitude for those wavelengths in various nanometers, then you end up with either infrared or radar or broadcast stuff. You go down, you have ultraviolet. This is where X-rays happen, and gamma rays below that. too high, too low a quantity of this, and you can definitely do damage. X-rays can cause, I do believe it's a known carcinogen. Gamma rays, and you turn into the Hulk. All right, let's talk about those waves. Okay, if we're looking at the various, in this case, we're going to do frequency. So of the peak to peak, if you have a short wave, you end up, if it's the cones that are picking up on light in that, it's going to look like it's a blue. It's a higher frequency as opposed to here to there. Now we're going to look like, if that's a longer thing, it appears to be red, or if it were a sound wave that we're picking up on in your ear with the cochlea, then it's going to be something that's going to sound low in frequency as opposed to a high-pitched and blue thing. If we're looking at not peak to peak, so not the frequency or the wavelength, but now we're making that heightening the top, the hill, the valley kind of video. Now the characteristic is going to change in a way that's going to be, we would describe it as amplitude. So this color, brighter or duller. Certainly, I hope you said brighter. And if you turn that down, so the one down here, this would be a dull color if the height from top to bottom is going to be decreased. Dull versus bright, blue versus red. Yay, eye parts. Okay, should take you about a minute or so. I'm going to give you a countdown. Go ahead and pause, draw, and label an eye. Let's look at stuff. Okay, frontmost part here will be down there on the bottom for the one I'm looking at. Cornea. Iris, we drew it as little slinky things, so a W or an M. In between the iris, you have a pupil. That thing right there that we drew as a racetrack. Lens. Back and around down here. I'm hoping you've got a retina. Best spot for vision. I just said it on a previous slide a minute ago. Fovea. That spot that can't see, easy enough. Blind spot. Going away from the eyeball is going to be an optic nerve. And then for bonus, we're going to what part of the brain? You've got two possible answers that would be, I'd be most proud of you if you had said the thalamus and then gets routed to the visual cortex, but eventually it's going to go to the visual cortex or the occipital lobe. That's the lobe on the cortex that does the vision stuff. All right, let's stop and pause again. What do these things do? What would be an appropriate descriptive if they asked you something or if they were prompting something about a part of this, a part of the eye? All right, let's start with the cornea. It's going to do the primary job of protecting, clearly not the only one, as you have eyebrows, eyelids, and eyelashes and stuff like that. That should do a better job with that. But the cornea is going to be protection and just to a small extent, some of the focusing. But I definitely want you to think of the lens as more of the focusing thing, the final focuser. Iris contracts or constricts or dilates, opens and closes, either to let in more light or keep out light if you've got an excess, if there's more than enough of it. And then it does that, and by opening or closing, the light goes through your pupil. The retina is the photoreceptive spot. It is the part that does transduction. Transduction, one more time, I'm gonna say transduction. Turning, in this case, we're looking at light into action potentials. All right, that actual process as it happens is called transduction, with rods and cones on the retina are going to do that. And as I just said a minute ago, cones will be in the more centrally located nearer the fovea and are going to do the color vision. Rods are going to do black and white or luminosity. Fovea is where you have the highest concentration of those cones, and you can see the color stuff. Ideally, whatever it is that you're looking at is going to be, you want that to hit onto the fovea so that you can, basically your peripheral vision doesn't do much and is not very acute, nor is it going to allow for any of the color. And then that information from each and every one of the rods and cones that are going to join up together to your bipolar cells, and then to even fewer of your ganglion cells. Well, all that image information will go out and down and through, since it's got to exit the eye, it goes through the blind spot, and then that's where it actually goes on and goes to the brain via your optic nerve. Yay, eye stuff. Hey, and I just said it, so this should be super easy. Okay, so this was called the summation process. If we're looking at actually breaking down what's on the retina and what that's going to do, you've got cones and you've got rods. You have fewer cones than you have rods. So since we've got fewer of these ones that are going to be in, I guess, red there, those are cones. The other ones are going to be rods, and they're going to send their signal on to, think of one side and the other, bipedal. Bifocal means two, so the two sides here. We're looking at bipolar cells. And I didn't click well. So there we go, bipolar cells. And some of these are going to link up to fewer of those and link up to fewer of those. Just the gist, the summary goes on. You don't actually have to pay attention to each and every single individual rod or cone that was tripped by a photon of light. So then we've got the ganglion cells, and the ganglion cells then take those on down to and through your optic nerve, out the blind spot to your thalamus, to the visual cortex. Yay. Hey, okay, when you look at this, it's going to change to the opposite color. What do we call that? Why does it happen? Okay, we're going to call that an after image. So you see the exact opposite. Green is going to turn to blue, black to white, and yellow to, wait, green to red. Sorry, I have color issues. Green's going to go to red, the black is going to go to white, and the yellow, that should be yellow, goes to blue. So it's going to look like a Union flag, or if you're at sea, then you call it a Union Jack. Otherwise, it's just the Union flag of the United Kingdom. It happens because of the opponent process theory. So rods are either going to see one thing or the other as they send their signal on, but they can't see both. And so the gist, G-I-S-T, of what's getting sent is what's going to go to the brain. And as your brain looks at this and it gets like a little bit tired and a little bit lazy and it stops kind of paying attention to whatever it is that's going on, as soon as you take one away, then it's going to see the opposite. So if you stare, 5, 4, 3, 2, and then I move it, you should be able to see what would normally be, you'd call the Union or Union Jack flag. All right, this puts me at 18 minutes if it takes you a couple minutes to get logged in, and then you're spending time, like I'm hoping you do, looking at the thing, and then hitting pause, accessing, it's called the test-retest method is what the value to this whole like learning process is. And if you're participating in it, I'm going to assume this is going to take you about as long as I'm supposed to be allocating time for you for this class. So I'm going to bring it to a close here. I hope you guys are doing well. Let me know if you have questions. Let me know if you need anything. All right, we'll talk to you guys soon.